All right, these are the notes for section 2.6 for college algebra. We are shifting from the whole graphing and transformation stuff that we've been working on to looking at functions and what their domains are. So that's the biggest thing today. Can we identify the domain of our functions? Right? The second thing we're going to look at is we're going to add, subtract, multiply, and divide two functions. All right, we're going to also look at what those domains would have to be. And then tomorrow we'll get into compositions of functions, if you remember those. All right, some other operations we can do with functions. So first of all, domain is what? If I asked you to define domain, what would you say? The x's, yeah. It's your input values, the x's. All right, whatever x's we are allowed to use for that particular function. There are two places where we typically have to worry about domains. All right, so take a minute, talk at your tables. Where do we have special rules about not being able to do things? Might help to look at the functions below this on the page. What are you seeing in those functions that might raise some red flags? I heard one of them. I heard the first one. Right? We can't have zeros as denominators. We cannot divide by 0. So when you look at all those functions on this page, you'll see some denominators. We're going to have to worry about that and do some domain restrictions. Anybody know the second one? Square roots. Yes. What can we not have in a square root? Negatives. All right? We'd get imaginary answers then. We don't want that. So we look for two things. Do we have denominators? If so, we have to make sure they're not going to be 0. Second one, do we have any square roots or any kind of even root? It could be a 4th root, a 6th root, okay, any kind of even root. We cannot have a negative value inside. Okay? All right, so we're not going to do anything with these questions other than just identifying the domain. Okay? For the first one, what's our basic shape here? It's a parabola, right? It's quadratic. Are there any domain restrictions there? Do we have a denominator? Do we have a square root? No. So our domain here would be everything from negative infinity to positive infinity. So all reals work. But in our second example, we do have a denominator. Individually, 3x plus 2, there's no restriction there. Individually, x squared minus 2x minus 3, there wouldn't be a restriction. But by putting it as its denominator, we've created a problem. So the easiest way to figure out what makes it 0 is to factor it. So take a second, factor x squared minus 2x minus 3. All right, what did we come up with? X plus 1, x minus 3. Agree, disagree? So what would create zeros? What values? A negative 1. So we want to say x can't be negative 1, and it can't be positive 3. Okay, so if you think about your domain, those are the two values you cannot have. And we want to always put our domain in interval notation. Okay? So we're going to pretend we're starting at the far end of our number line. We're just going to walk and we're going to jump over the things we can't have. Okay? So I'm going to start over here at negative infinity. And I'm going to walk towards what's my first jump? Negative 1. I have to skip over it. So I'm going to get to negative 1 and I'm going to jump over it. So those rounded brackets imply that I'm not including negative 1, right? Then I'm going to go to what number? 3. Then I have to go and jump over 3, and then I can keep going all the way to positive infinity. Okay? So when you look at this notation right here, that means that we are skipping over the negative 1 And right here implies we're skipping over a positive 3. Does that make sense? Okay. Question 3. What's the issue with this one? There's a square root. All right, we said we can't have negatives inside our square root. So we have to look at that expression, that 3x plus 12. And we have to say we don't want this to be negative. That means it could be 0 or it could be anything higher, right? Anything positive. So we're going to say that 3x plus 12 has to be greater than or equal to 0. Okay? Now, let's solve for x. So we're going to bring our 12 to the other side and then divide. So we end up with x having to be greater than or equal to negative 4. Does that make sense? So in our interval notation, I would say my domain starts at negative 4, and then it can be anything higher than that. Okay? Question 4, now we've combined both issues. We have a denominator, and inside that denominator is a square root. So if I didn't have this top part, the 3x plus 2, if I just had this, I would say that 14 minus 2x can't be negative, right? But because it's in the denominator position now, it also can't be 0. So for this particular question, 14 minus 2x now has to strictly be greater than 0. It can't be equal to it anymore. Does that make sense? Okay. How would we solve that? Okay. And then I added it to this side. And then divide by 2. So reading from x, we have x has to actually be smaller than 7. Okay. So for my domain, I want to be under 7. So from negative infinity up to 7, but not including it. Because if I actually put a 7 in there, it would make it 0. And I can't divide by 0. Okay. Questions on any of the first 4? Denominators can't be, everybody, denominators can't be 0, and square roots can't have a negative under it. Okay. Our next 2 are a little different. We're back to dealing with denominators, but we actually have 2 places we have to worry about. We have a small fraction right here, yes, that x is a denominator in. So x can't be 0. So from this, we would say x cannot be a 0. But I have a different denominator. I have this whole thing as the denominator of that 5. All right? So I have to make sure that whole thing I just put in the blue box isn't 0. So we need to say that 4 divided by x minus 1 cannot equal 0. And then we'll solve to figure out what would make that happen. So my first step would be to add the 1 over. And then I'm going to multiply the x over. Now check it. We just came up with saying that x can't be a 4. If I put a 4 in here, 4 divided by 4 is 1. 1 minus 1 would get me a 0. Okay? So take a second and write out your domain. You have to jump over a 0 and a 4. All right, and then check your answer. Any questions on that? Okay. problem 6, very similar. We have one fraction right here. So what can x not be? X can't be a 2. Okay. Then looking at the bigger fraction, that's my denominator. And so 4 over x minus 2 minus a 3, that whole thing can't be 0. Okay? I'm going to pause the video. I want you guys to try solving that. All right, checking our work. I added the 3 to the right-hand side. I multiplied the x minus 2 over to the right-hand side, distributed, and then got my like terms together. So we end up with x not being 10/3. We good with that? All right, so how would we write our domain? We said x can't be a positive 2 and it can't be a 10/3. How big is 10/3? 3 1/3. So the first number we're going to jump over is 2. And then we'll jump over the 10/3. If you want to write it as 3 1/3, you can. I'm going to leave it as 10/3. Okay. All right. Question 7 here. We have 2 square roots. So when we look at this, we've got 2 places for restrictions. For this one, x minus 3 can't be, sorry, x minus 3 has to be what? What would I put in there? What can I not have under a square root? Can't be negative, so it has to be 0 or higher, yes? So x minus 3 has to be greater than or equal to 0. Okay? For this one, x plus 4 has to be greater than or equal to 0. Go ahead and solve for x. Now, we have 2 statements. One says that x has to be greater than or equal to 3. One says that x has to be greater than or equal to negative 4. What do we use? You have to look at which one is going to be more restrictive. Okay? So think of a number line. We've got negative 4 here. We've got 3 here. If x has to be greater than or equal to this, that means I can use every number to the right of negative 4. Yes? But would that work in that one? No. So this other restriction here from 3 on up is more restrictive. It limits more numbers. Okay? Would values from 3 on up work in both square roots? Then that's what we have to use for our domain. Okay? Questions on domain restrictions? Okay. The second objective that we had today was just to simply add, subtract, multiply, and divide functions. You've done this before. We are going to look at domain restrictions here as well. Okay? And the one thing to consider is sometimes when we manipulate functions, we either create more domain restrictions or we seem to hide some. When you're looking at the domains here, you have to consider all the way through. Was there a restriction at the beginning? Is it still there at the end? Doesn't matter. If it was a restriction at the beginning, you still have to include it. Did we do something during the problem that created another domain restriction? Then we'd have to include that as well. Okay? We're going to start out with some basic functions. I just want to clarify the notation. What you see here, some books will write it like this. Some books will write it like this. They mean the same thing. What this is telling me is I have 2 functions. I have function f and I have function g. Both are using x as the variable, and I want to add them together. Where the confusion has come in the past is some students see this and think, oh, I'm supposed to add f and g together and then times by an x. Okay? That doesn't mean you're timesing by an x. It's just indicating that x is the variable that's being used in the functions. Okay? So in either case, whatever book you encounter, they mean the same thing. Yes? But you're not multiplying by x. Okay? All it's saying is that x is the variable. Okay. So we have adding, subtracting, multiplying, dividing. We do have to be extra careful with division because what did we create? Created a denominator. Okay, so there might be some extra domain restrictions that have to come in. Okay. Also be careful here with subtraction that you're subtracting the whole function that comes after it. Okay. All right, so our first examples here, we have some pretty basic functions. F is just an x minus 5, g is an x squared minus 1. Are there any domain restrictions at the beginning here on either f or g? Is there anything x can't be here? Do you see a denominator or a square root? Okay, then there's no domain restrictions. Is there any domain restrictions on this one? No. So right now we're thinking x can be anything. Okay? This says I want to add the two functions together. And you can leave the x off if you want. You don't have to put it in there. Just I'm adding f and g together. So I'm going to take x minus 5 and I'm going to add to it x squared minus 1. Okay? All I want you to do here is simplify what you can. If there's like terms, put them together. So in this case, I would put my x squared first, then I have a positive x, and I can combine the minus 5 and the minus 1 as a minus 6. Okay? Any square roots or denominators that I've created? All right, so my domain here would be everything. All right, for our second one, same two functions, but this time we're subtracting. All right, so we're going to take f minus g. We're going to take x minus 5, and we're going to subtract an x squared minus 1. I made that subtraction very large, so I didn't miss it. Okay? I have to now distribute that minus sign to the function g. So I have x minus 5 minus x squared, and then plus 1. Okay? Combining like terms, putting it in standard form. I have a negative x squared, a positive x, and a negative 4. Any domain restrictions on that answer? No. So domain is still all reals. Okay. F times g. We're going to take x minus 5 and multiply it to x squared minus 1. Take a second and FOIL that out. Check your answer when you're finished. I did a little rearranging as I wrote it up there to put it in standard form. You certainly can do that as a second step. Any domain restrictions for that one? Okay. Question 4. We're dividing now. And we said with division, we have created a denominator. So let's think of that in its factored form. X squared minus 1 factors into, okay? So what are the values I cannot use? Positive and negative 1. Okay, so for my domain, I'm going to start at negative infinity. The first number I have to jump over is negative 1. Then I can go from negative 1 to 1. jump over 1, and then keep going. Okay? Questions on the adding, subtracting part? Multiplying, dividing? Okay. I do want to do a set where the functions are a little more complicated, because you will have a few like this in your homework. Do we have any domain restrictions on function f? Yes. X cannot be 4. Do we have any domain restrictions on g? X cannot be -8. I ask you to write those down initially before we even start adding, subtracting, etc., because sometimes in our process we'll lose a domain restriction. It'll kind of disappear from my answer, but it's still there. Okay? We cannot add these two functions together if x is a 4 or a -8. Okay? So we have to keep those all the way through. All right, adding. We have a little problem here because we're trying to add two functions and we do not have common denominators. So we have to get common denominators to simplify this. So what am I going to have to multiply to the first fraction here? Okay, I need an x plus 8 on that one. And then on the second one, I need to multiply by x minus 4. So do the denominators match now? Okay, so my denominator will have an x minus 4 and an x plus 8 on it. Okay. Numerator, what do we get? 9x squared plus 72x, good. And then for the second part, we're adding a 7x and we're adding a -28. Okay, just distributing. Combining like terms, we could put those x's in the middle together. So 9x squared plus 79x minus 28. I am going to let you leave the denominator in factored form because it helps us make that domain restriction more obvious. Okay. If you were checking an answer and the back of the book had foiled it out, just know that you can, that's equivalent. Okay. So domain restriction for this would be what? I start at -infinity. What's my first jump? -8. Skip over -8, go up to 4, jump over that, and keep going. All right, we're going to save ourselves a little work on the next one because the next one just says subtract instead of add. So a lot of my work is still going to be the same. My change is that now I'm going to put a minus sign right here. Yes? So that changes all the signs of the stuff after it. Does that make sense? So let's go from this step. We're going to have a 9x squared plus 72x. That would still be the same. But now we're going to, if we subtract all of this, we're going to subtract a 7x. And we're going to actually add a 28. Is everybody okay with that? We don't want to create more work if we don't have to. Combining like terms. I now have 9x squared plus 65x plus 28 over x minus 4x plus 8. Would the domain be different than what I have for question 1? Okay, so same domain applies there. All right. We're going to multiply next. We're going to take f times g. So 9x over x minus 4, and we're multiplying it to 7 over x plus 8. Again, I'm okay with you leaving the denominator in factored form. So numerator becomes 63x. Denominator we're going to just leave in its factored form. Anything different for our domain restriction from our first answer? Still the same? Okay. Question 4, dividing this time. So f was 9x over x minus 4. We're dividing by 7 over x plus 8. How do we divide by a fraction? Okay, so let's rewrite this. 9x over x minus 4. We're going to multiply by the reciprocal, which would be x plus 8 over 7. All right, take a minute and distribute. I'm okay again, denominator, you can leave it like this. You can distribute that 7. When I look at my final answer, it looks like the only thing x can't be is a 4. However, up here, x can't be negative 8, right? So even though that disappeared, it doesn't show up in my final answer, it still is a domain restriction. Okay? I also have created this as a denominator of the whole top. So I would have to look at that and say, would that ever become 0? In this case, it doesn't. If you try solving it, 7 over x plus 8, we're saying equals 0. But if I multiply this over to here, 0 times that is 0. So I end up with 7 equaling 0. The x is gone, and so there's no x value that would make that 0. But with a different kind of expression, you might have had an issue. Okay? So domain for this last one is going to be the same as what we've had for all the other ones. Okay? All right, the last one, I'm going to pause the video for a minute. I want you guys to try that one at your tables. All right, for our last question today. There are no domain restrictions initially on function f or function g, but I am doing a division problem. So I've created a denominator. So what can x not be from that denominator? Negative 3/2? Okay, so we will have to keep that in mind. Can you factor the numerator? Because we want to simplify this down as far as we can go. We actually can. The 2x squared here would factor into 2x and x. To get a negative 15, we would think 1 and 15, 3 and 5, right, with one negative sign. Any ideas of what works? What would I put in the first one? Positive 3 and then negative 5. So inside I get 3x, outside I get negative 10x. That's where my negative 7x in the middle comes from. Okay? So what's going to happen when I try to simplify this? Yeah, the 2x plus 3's cancel out. So my final answer is x minus 5. But I still have the domain restriction of negative 3/2. Okay? So my domain here, I start at negative infinity, I go up to negative 3/2, and I jump over it. And continue on to positive infinity. Okay? Questions? All right, here's your assignment.